Hey guys, and welcome back to a new video. In this video, we will learn about the remaining views that we didn't discuss in the previous video. And this is also going to be the last video introducing you to views and UI components, as the aim of this playlist is to make you ready for Android development as a beginner. Nevertheless, what we have talked about so far are not only the views within the Android ecosystem. Android is filled with different UI components and layouts that we cannot cover within a single playlist, and most professional Android developers do not know about all the views within the Android ecosystem. And even if they do, they will probably Google or look up for different things related to the views that they are using. So take this as a tip to always look up for different things, different errors, different solutions for the platform that you are developing for, or the library that you are using, or whatever technology that you are discovering. Additionally, never depend on a single resource for learning. You should have a handful and variety number of resources to learn from to strengthen your skill set. Without any further delay, let's learn about the radio button. So a radio button is pretty similar to the checkbox, toggle button, and the switch. However, it is mostly used to select a single option from a set of related options. So let's drop a radio button from the palette. And here I'm going to drop 3 radio buttons. I'm going to copy this over and paste it 3 times. Ctrl+C, Ctrl+V twice. Now we are going to constrain these radio buttons to the start of the parent with 16 dp margin, and then we are going to constrain this to the bottom of the text. Now let's add our margin values. Now in this example, what we want to do is whenever we select any of these radio buttons, we want to manipulate the attributes of the text view. But before doing that, let's run our application to see how these radio buttons are toggled on and off. So here, as you can see, if you selected the first radio button, it's now selected. The second one, it's now selected. The third one, it's now selected. So they are all selected. But if you remember, we said that the radio button is used to choose a single option from a set of related options. So what we have to do here is to go to the main activity class, and then whenever we select any of these radio buttons, then we have to unselect the other radio buttons. But this is a lot of work. Imagine if we have hundreds of radio buttons within a single screen, then we have to write hundreds lines of code. And for this, we have to put the radio buttons into a group. And this group is called radio group. And the radio group acts as a view container for the radio buttons. So it can contain the radio buttons, and whenever we select any of the radio buttons, it will automatically unselect the other radio buttons. So instead of having this here, we will put the radio group. So open the tag, add the radio group, wrap and wrap. So instead of closing the radio group with the closing tag for views, we'll open the body of the radio group and add our radio buttons within this group. But before that, let's just delete all the constraints of the radio buttons, because now we will constrain the radio group as it contains the radio buttons. So select all of them, then right click and clear constraints of the selection. Now we will take all the radio buttons and we will put them within the radio group. So here we will constrain the radio group to the bottom of the text. So top bottom to the text view, and start to the parent. Lastly, we add our margin 16 dp. So cool, let's run to test this out. So as you can see here, if you clicked on any of these radio buttons, it's now selected. Try to choose another one. The first one is now unselected and the other one is selected. So the radio group helps us to reduce the lines of code that we need to write to handle this process. Now let's continue with our example. So if you clicked on the first radio button, we want to make the text bold. So here I'm going to name it make bold. And you can change the text of the radio group with the text attribute that we are used to. You can also play around with the colors of the radio group by using the button tint attribute that we used before. So for example, I want to change the color of the circle. Here it's cobalt, maybe make it purple to be more evident. And now if you make the radio button checked with the checked attribute, make it true, you can see now the color is changed. Let's change the color for the other radio buttons as well. And now I will change the ID of the make bold and make it RB bold. The second one is used to make the color or the text color red, so make red. And here RB red. And finally, this one is used to change the text of the text view. So RB text. And here, make hello world, because we are going to change the text of this text view to hello world. Cool. The only thing left to do is to give an ID to our group, so we can easily access it from our main activity class. ID, name it to RB group. Now let's go to the main activity class. And here we can refer to our group, binding.RB group. And with the group, if you add the dot, you can see here we have different methods and different attributes that we can use to customize this group programmatically. So the first one is the check. And here for the check, you pass an ID of your radio buttons if you want to be checked. So for example, if you have a click listener set on a button and you want to check a radio button once you click on that button, then you add the ID of the radio button here. You can also see set on change checked listener that we used before. We have also clear check, which clears all the selection of the radio buttons, and remove view, which removes a radio button from this radio group. And if you look down, we have the checked radio button ID, which returns the ID of the current selection of the radio button. Now what we want to use here is the set on checked change listener. So again, here we have to create an object that implements the onChecked change listener. But notice that the onChecked change listener here comes from the radio group class, not from the compound button class that we used before. So here, make the object, implement the onChecked change listener interface, and make sure it comes from the radio group. Then open your curly braces or the body of this interface. Ctrl I to implement the single function, or you could just replace all of this with a lambda. Hover here and convert it to a lambda. Now here the function is passing to us two things. First one is the group, which is the radio group, and finally the checked ID, which is the current selection of the radio buttons. So what we want to do here is to first check if any of these radio buttons are selected, then we are going to add the code to manipulate the attributes of the text view. So instead of having if and else blocks, we will use the when conditional statement. Here we'll add checked ID. So we will check if first this ID is r.id.rb bold, and here again r.id.rb red, and finally we will add the else clause, because if it's not the radio button bold or the radio button red, then it's definitely the radio button text. So add the else block. Now when the radio bold is checked, what we want to do is to make the text bold. So you can simply do this by referring to binding textView.typeface that we used in the textView video equal to typeface default bold. And when the red is selected, then binding.textView.set color. And here we will pass the red color from the color class. Finally, for the text, binding.textView.text is equal to hello world. Finally, let's run to test this out. Let's check the bold radio button. You can see now the text is red. Make the red. Text is now red and bold at the same time. Make the hello world. The text is hello world, red and bold. So what we want to do here is to remove the effects of the other radio buttons whenever any of the radio buttons are selected. So for example, if the radio button bold is selected, then we want to make the text color to gray, which is the default, and the text of the text view to sample text, which is also the default. So if RB is selected, then make the color gray, the text to sample text. And we add the same lines of code with some minor modifications in the other lines. So within every of these radio buttons here, we undo the effects of the other radio buttons. So if it's bold, we make the text color to default and the text to default. If it's red, we make the style to default and the text to default. If it is text, then we make the color to default and the style to default. And now let's run to see the result. Make hello world, the text is now hello world. Make red, the text is now sample text and red. Make bold, text is bold and the color is default and the text also is default. Now it's always recommended to use the radio buttons within a radio group, so never use the radio button within a single group. However, if you have some design requirements that require you to use the radio button without using the radio group, then here you can add a checked listener for your radio buttons. So if you refer to any of the radio buttons that you have, for example RB red here, you can set on check listener again that comes from the compound button class. So it's the same interface that we used before with the toggle button switch and the checkbox. You can also get the current state if it's checked, or for example you can change the state on some event, for example when the button is clicked. Now moving to the SeekBar. The SeekBar is a user interface element that allows the user to adjust a value from a range of values by dragging a slider. It's pretty much similar to the bars that you see in videos or music applications. Now in our example here, we are going to use the SeekBar to modify the attributes of the image filter view. If you don't have any experience with the image filter view, refer back to the helpers video in this playlist. So what we have here is just an image filter view, and we have a couple of text views that will represent the SeekBars. So here this one is used to control the saturation of the image, the brightness, crossfade, round percent, and finally the contrast. And you can see here we also have this barrier here that is set at the end of the view or the text view that has the maximum width. And I will use this barrier to constrain the SeekBars to it. Anyway, for this layout, I will leave a link to the description below for this actual layout, so you don't need to create it yourself from scratch. So here I'm going to add a SeekBar. Go to the palette, search for SeekBar, and here we have two types of SeekBars. We have the discrete one and the normal one. Both function the same, but the only difference between them is just different style from the material library. So if you, for example, drop a SeekBar, you can see this is the style of the SeekBar. Let's just make it match the constraint of the parent or match the parent, so you can see it correctly. Make it here. And now if you drop a SeekBar discrete or discrete SeekBar, make it again match parent. You can see it's slightly different than the normal SeekBar. You can see both of them have the same attributes, both of them start with the same tag, but they only differ in the style of them. So this one having a discrete style, if you remove discrete word, it will turn into the normal one that we have added. So anyway, let's just delete the SeekBar discrete or the second SeekBar and make this one wrap content. So you'll have around 5 SeekBars. Copy this over, paste it 4 times, and we are going to constrain all of these to the barrier from the start. If it doesn't work from the design tab, then you could do it here from the code tab. So start end of the barrier, and the top of the SeekBar to the top of the text, and the bottom of the SeekBar to the bottom of the text. Then just constrain it to the parent and make it 0 dp for the width, and for the height make it wrap content. Finally add some margin around 16 dp, and we are going to apply the same constraints but with the corresponding text view to the other SeekBars. So I'm just going to do this very quickly. Now after we're done constraining the views to the corresponding text views and to the parent and add some margin, etc., we will talk about the different attributes of the SeekBar. So here we have an attribute called max to determine the maximum value of the SeekBar. So if you, for example, determine that the max value of the SeekBar is 100, then you can play around with the progress attribute to change the progress of this SeekBar. So around 15, you can see it just moves 15 steps. Around 50, it moves to the half of the SeekBar. 90, it moves almost to the end of the SeekBar. Additionally, if you want to change the colors of the SeekBar or the thumb of the SeekBar, we can use the following attributes, starting first with the progress tint, which changes the color of the progress bar. So here I'm going to make it purple. You can see it changes to purple. If you want to change the color of the thumb, then we can use the thumb tint attribute. Again, we will make it, for example, black, and we will apply the same attributes to the other SeekBars. So now we said that we are going to manipulate the different attributes of the image filter view with these SeekBars. So according to the documentations, saturation only has 3 possible values: 0, 1, or 2. So instead of making the maximum value for this SeekBar to 100, we will make it 2, as it will start from 0, then 1, then moves to 2. corresponding to the saturation values. And for the progress, we don't need it for now, so we are going to delete it. Now for the brightness, again, the brightness only has 3 possible values, 0, 1 or 2. So here we will make the max value for this SeekBar to 2. Now for the crossfade, we can mix a value between 0 and 1 or maybe 1 or 0. So here we'll make the crossfade max value to 100 and we will change that programmatically to match a value between 0 and 100 to 0 and 1. So here we will just make it 100. And for the round percent, again, we can use different values between 0 and 1. So the maximum value for the round percent is going to also be 100 and we will change that programmatically. Finally, for our contrast, 0, 1 or 2. So again, the contrast will have maximum value of 2. Now before moving to the main activity class, we will just change the IDs of the SeekBars. So this one is called SP contrast. And this one is going to be SP round. So I'm just changing them to a more readable and meaningful ID so I can know what SeekBar is it. So this one is going to be SP crossfade. Now we'll move to the main activity class. Let's just delete all the old code from the radio buttons and here we'll add our code for the SeekBars. So the SeekBar has a listener also to listen for the different events when you slide the SeekBar across its track. And we can do this by referring to any of the SeekBars. So SP brightness.set on SeekBar change listener. And here you have to implement on SeekBar change listener from the SeekBar class. So object that implements on SeekBar change listener. Open the body, Ctrl I to implement all of these functions. Now we won't use all of these functions, we're only going to use the first one. So I'm just going to shorten this function or shorten the body of this function so it doesn't occupy a lot of space here, and we'll only use this function. So this function passes 3 things. First, the SeekBar, which is the actual SeekBar that we are registering this listener to, then the progress, and finally from the user. That determines if this movement of the SeekBar is happening from the user or programmatically. So what we are interested in is only the progress. So the brightness, we said that we have 3 possible values. So here we will change the image filter view brightness to the progress. But before this, the progress is passed as an integer, so we have to convert it to a float. Now we're going to add the same listener to the other SeekBars. Now for the contrast, we said that it has 2 possible values, so we are going to leave it as the same, but we would just change from brightness to contrast. Now for the crossfade must have a value between 0 and 1 or 1 or 0. So instead of just passing the integer, which is a range between 0 or 100, we will first multiply the progress by 0.01f, and this will convert it to a float and it will shorten the value to be between 0 and 1. So for example, if it's 20% or if the value is 20, then it's going to be 0.2. Now let's move to the round. Here again, we're going to apply the same procedure. So progress multiplied by 0.0f, and finally the saturation. So the saturation has 3 possible values, 0, 1 or 2. So we will just pass the progress after converting it to a float. Now let's run to see our result. Now, as you can see here, we will first start with the saturation. So you can see the saturation is changing between the 2 screens, between the 2 images. You can also play with the brightness. Crossfade is happening between the 2 pictures. Round percent, you can see the images are being slightly rounder. And finally the contrast. You can also enhance this application by giving the default values for the saturation. So the default value for the saturation is 1, so we will set it to 1 from the XML code, for example, with the progress attribute, as well as for the brightness, as the original is 1, so 1 for the brightness. The crossfade 0 as the default value. your ampersand is also 0, and finally the contrast, which is also 1 as the default. Now moving to the chip. A chip is a small compact UI component that represents an attribute, text, entity, or action. It's typically used to display complex information in a compact form, such as tags, contacts, choices, or actions. So let's just drop a chip from the palette. So here, write chip and drop a single chip. And you can see this is how the chip looks like. Now let's talk about the different attributes of the chip. So you can add a text to the chip with the text attribute. For example, chip 1. You can also add a chip icon with the chip icon attribute. And here I will refer to, for example, the face, IC face that we used in the previous videos. And if you want to change the icon color, you can use the chip icon tint. And here I'm going to pass the purple color. Additionally, you can change the background of the chip with the chip background color attribute. Here, for example, I'm going to pass teal 200. As for the corners of the chip, you can modify them with chip corner radius attribute. So if I pass 100 dp, you can see it's more rounder than before. 10 dp is now slightly rounder. 0 dp now a rectangle rather than a rounder shape. The chip actually has a lot of attributes. You can also add the close enabled, which adds a close icon to your chip. Make it true. You can see here is the close icon. If you wish to change the close icon, then you can use the close icon attribute and you can add your own close icon. For example, I'm going to pass IC Android, but I will leave the default one because it's more convenient. And we also have the stroke color and stroke width attribute to add stroke to your chip. Finally, you can play around with checked and checkable. So checked adds a check mark to your chip. If you set the checkable attribute first to true, you can see now your chip is checked. And finally, you can modify the checked icon with the checked icon attribute. So here, instead of this check, you can add your own drawable, your own vector asset instead of the default check mark. Now let's look at the different listeners that we can register to our chip here. For that, I want my chip to be rounded instead of a rectangle shape. So I'll delete the chip corner radius. And now I'll move to the main activity class. And here we can refer to our chip, then we can set on checked change listener. You can also set on close icon checked listener, or set on, which we have used before with the buttons, the fabs, and you can possibly add with any other views. So instead of using the set on click listener, we will use set on checked listener. Again, that comes from the compound buttons, so we know that it passes the view and the is checked attribute. So we will just write the lambda instead of implementing the interface. Additionally, we could register the set on close listener. So binding chip set on close icon click listener. And here it just passes the view. So when the chip is selected or when the chip is checked, I want to create a toast saying checked. And if it is closed, then again create a toast, this closed. And finally, I want to remove the chip from the view. So you can do this by referring to the root, binding root dot remove view, and here I will pass it, as it here refers to the view that the check listener or the close icon click listener passing, which is eventually refers to your chip. So let's just run to test this out. So as you can see here, if we unchecked it, it's now calling the check. If it's checked, it's again calling the checked. We had to check first. If it's checked, then we create a toast checked. If it's not checked, we create the toast it's not checked. However, you can do this by your own. And finally, if we click on the close icon, now the view is removed and the closed toast is displayed. So chips are usually used in groups. We have a container called chip group that can contain one or multiple chips. Chip group provides functionality to select one or multiple chips, and it enforces single selection if desired, as well as scrolling through the chips within a group if they go beyond the bounds of the screen. So let's add a chip group, And here we will add chip group, wrap and wrap, and now we'll open the body of the chip group, and within this chip group we will add our chip. And instead of giving constraints to a chip, you can give constraints to the chip group. So I'm going to constrain to the end of the parent, start of the parent, top of the parent, and make it 0 dp to match constraint for the width. Now I'll add another chip with the same attributes. And I'm just going to change the text of the other chips along with the ID of the other chips as well. Now let's talk about the different attributes of the chip group. So let's start first with the single selection attribute that enforces single selection between all of these chips within the same group. So you can see all of our chips are selected. If we add the true or true for the single selection attribute, only one chip is selected. And if you want to control which chip is currently selected, you can do this by using the checked chip, and here you can select which chip is currently selected. So instead of selecting the third chip, I want to select the first one. And if you don't like the default spacings between the chips, you can always configure this with chip spacings attributes. You can see here we have the general spacing, the chip spacing horizontal, and the chip spacing vertical. In this case, I want to control the horizontal spacings of our chips. So here, for example, I'm going to add 100 dp, and you can see one of the chips are moved to the next line. But what if I don't want this behavior? I want all of them to be within the same line. So for this, we can use an attribute called single line, and here I'm going to make it true. And one of the chips now is outside the bounds of the screen. Now what we want to do to access the third chip is to scroll through the chip group to access it. And we can do this by adding a scroll view as a parent to the chip group. So the scroll view here is not only limited to be used with this chip group, you can use it also to scroll between your views or make your layout scrollable for smaller screen sizes. But always make sure to make it as the parent of the whole layout. So in this case, I'm not going to make it the parent of the constraint layout, as the constraint layout, I don't want to scroll through the constraint layout. What I want to scroll through is the chip group. So here I'm going to make it the parent of the chip group. And instead of using the scroll view, I'm going to use the horizontal scroll view. Make it wrap and wrap, or for the width, just make it match constraint. And now open the body of the scroll view and insert your chip group within your scroll view. So make sure the cursor here is on the chip group. Now press Ctrl Shift and the forward arrow. And here our chip group is within the horizontal scroll view. The only thing we are left to do is to add constraints to our scroll view. So constraint to the top of the parent, start of the parent, and to the end of the parent. And now let's run to see the result. You can see here, once you open the application, we are now can scroll through the chips to reach the last chip within the same group. So the horizontal scroll view could be useful if you have a lot of chips within a single chip group, or you have a lot of views that can go beyond the screen in smaller devices, or for example if you have a very long text that can go beyond the screen in even large devices. So that was it for today's video. Thank you for watching, and I hope to see you in the next video.